Hi class, welcome back to the lab. Today we are going to be going over starch hydrolysis. So I'm going to talk a little bit about starch, what it is, talk a little bit about hydrolysis, the enzymes that are responsible for doing the hydrolysis, and then we're going to go over to the workbench, inoculate some starch, and then read the results. So starch hydrolysis, let's just first talk about what starch is. So starch is a polysaccharide, okay? So it is a carbohydrate. It's a sugar. All those words are interchangeable. They all mean the same thing. Carbohydrate, polysaccharide, sugar. They basically mean the same thing. Starch is found in plants. Okay? Our bodies do not make starch naturally. And starch is a very, very large polymer. Okay? So it's made of a bunch of monomers linked together. Those monomers are glucose. And like I said, it's really, really large. So the bacteria would love to utilize the starch as a nutrient source, but it can't use it the way that it is because it's too large. So the bacteria has to break the starch down before it can bring it into the cell. So it breaks it down into the glucose monomers. Then those glucose monomers can be brought into the cell. So that's what the hydrolysis part is. Hydrolysis means breaking a bond using water. Hydrolysis. Lyse, you're breaking using hydro water. So the bacteria produces an enzyme that is assisting in this hydrolysis. The enzyme is called amylase, and it is an exoenzyme. So it's an enzyme that is produced outside. It's made and then brought outside of the cell. That enzyme breaks those bonds in the polysaccharide and starch to break it down into the smaller monomers, and then that glucose can be brought into the cell and utilized. Now, if the bacteria does not have amylase, it cannot break the starch down, so it's not going to be able to eat the starch. So if it does not produce amylase, it is not going to be able to do starch hydrolysis, and that's what we're going to be asking today. Can the bacteria hydrolyze the starch, yes or no? Or in simple terms, can it eat starch? So what we're going to do is we are going to use what is called starch agar, and it's in a petri dish, and we are going to inoculate that with our bacteria. We've got two bacteria that we're going to use today, E. coli and bacillus. One of them is positive for starch hydrolysis. One of them is negative for starch hydrolysis. So we are going to inoculate those plates, incubate them for 24 hours, and then we're going to come back and read the results. Okay? To read the results, we are going to need to add an indicator to the plate. The indicator is iodine. Iodine reacts with starch and turns black. So if our bacteria did not produce amylase and did not hydrolyze the starch, all of the starch should still be in the plate. So when we add the iodine, the entire plate should turn black. That means that all the starch is there and our bacteria did not hydrolyze the starch. If we add the iodine and we have a halo of clearing or an area of clearing around the colonies, that means that that bacteria ate the starch. There's no starch around the colonies, so the bacteria took it in and utilized it. And you'll see that it's called a halo of clearing, okay, where the iodine was put there and there was no starch there for it to react with, so it stays clear. And a lot of times the outer part of the plate will be black, and then just that, hey, you'll see just that halo of clearing around the colonies, okay? So let's go to our workbench. We're going to inoculate some plates, and then we'll read some results that I have ready. Okay, so we're back here at the workbench, and we are going to inoculate our starch plate. So here's what the starch looks like. Starch plates look like. You can't really see anything. Okay, there's nothing on it right now. It's a little condensation from being in the cooler, but that's it. And so what we're going to do is, we're not going to do a streak plate for these. So we're not worried about getting an isolated colony or anything like that. We are going to just do a line straight down the center, because remember how we want to read the results. We want to be able to see a halo of clearing. Well, if we cover the entire plate with bacteria, we're not going to really be able to see any halo. So we're going to just do a line straight down the center. And the tool that we need for this is our loop. And we're still going to practice aseptic techniques. So we're still going to flame our loop and do all of that. So I'm going to get my Fireboy going. And the bacteria, like I said, that we use is E. coli and Bacillus for this. So I've got my E. coli and I've got my Bacillus. Fireboy is acting up a little bit today. Alright, so we're going to let our loop cool. Of course, we don't want to burn our bacteria because we do want them living. So we're going to let our loop cool a little bit. And then all I'm simply going to do is take a little bit of my bacteria and just glide along the top of the agar. Of course, we don't need to stab the agar. The bacteria is going to go right on top. So we're going to, first I'm going to do the E. coli. So I'm just going to take my tube, glide across the top. It doesn't take a lot. You're probably not going to see a whole lot on the end of your loop. And then I'm going to take my plate and drag it across. And that's it. That is literally all that you do. So I'm going to do my other plate of Bacillus. And of course, normally you would want to label these with what they are, your name, and all of that. I've already got my results here that I'm going to be reading that are labeled, so I'll show you what that looks like. But I just want to demonstrate the process of inoculation. So here's my Bacillus. Going to simply do the same thing. Go in, slide across the top, and then I'm going to do the same exact thing. Try to find the middle, and then just glide across the top. And like I said, you're not going to see anything right now. All you're going to see is your streak mark because the bacteria has to take 24 hours to grow, and that's what happens in the incubator. So, after they incubate for 24 hours, we get this. So here's my starch. The STA stands for starch, and then I've got my E. coli and I've got my Bacillus. Okay, and you see that's my nice straight line that I drew. But remember, right now they look exactly the same, right? There's not a whole lot of difference there. The Bacillus colonies are a little bigger, but other than that, there's no real difference. So we need to add our iodine. So what we're going to do is we're going to use, it's the same iodine that you use in the gram stain, okay? And we're just going to we are going to open our plates, and we are going to flood them with the iodine. So we're going to cover the plate with iodine. Now remember, the iodine is reacting with starch, okay? So a lot of people get this confused. They think that the black color equals positive, but that is not the case. If you get a full black plate, that is actually negative for starch hydrolysis because that means that all of the starch is still there. And remember, we're going to be looking for a halo, an area around the colonies. So we're not looking at the colonies themselves. They're going to be white, okay? We're not looking at that. We're looking at the area around the colonies. So now that I've given the iodine a few seconds to react, I'm going to pour the excess iodine off, and then we are going to look for that halo. Okay, so remember I said that we're not looking at the colonies themselves. The colonies are going to be white, so be careful whenever you're looking at this. So here's my E. coli. So you can see the colonies going down the center. Those are a yellowy looking color. Okay, but is there a halo going around those colonies? Looks pretty black to me. Okay, so if we take our Bacillus and we look at that one, you can immediately see that there is an area around the colonies that is clear. Now, it's got a yellowy looking tint to it right now because of the iodine, but you can see that area of clearing around the colonies, and that's what we want to see. Okay? So yeah, there we go. You can see that area of clearing around the Bacillus. So Bacillus is positive for starch hydrolysis, and E. coli is negative for starch hydrolysis, because you see the area around the colonies, there's absolutely no clearing. All the starch is still there. So the E. coli cannot utilize starch. It does not produce amylase. Bacillus does. See the nice clearing around the colonies. Okay, so that's all that you need to know for the starch plates. You see clearing, it's a positive. You see no clearing, and that is a negative.